Today we're going to do lesson 1.2, which is understand irrational numbers. So we're going to be classifying different types of numbers, and you're going to be introduced to a lot of different vocabulary, some of which you might be familiar with, and some will be new. So we're going to start by looking at example 1. So example 1 says identify irrational numbers. So a couple of things just to go over before we dive into what irrational is. There's some things that you should already be familiar with. So a number that can be expressed as an integer, okay, integer we should be familiar with, or a ratio of two integers is a rational number. Okay, so a rational number is an integer or a ratio of two integers. Okay, so a lot of times you'll hear a ratio can be written as a fraction, where there's a number in the numerator and the denominator. So it can either be an integer, so a whole number, or it could be something like 1/2. 1 over 2 is a ratio of two integers. So again, a number that can be expressed as an integer or a ratio of two integers is a rational number. When expressed as a decimal, the decimal is either terminating or repeating. So with a rational number, it's really important to remember that the decimal form terminates. So that means it ends or it repeats. Okay, so it keeps on going forever and ever, but there's a pattern there. So some examples of this would be 0.25. That's a terminating decimal. It ends. A repeating example would be something like 0.3 with a bar over it. Okay, that signifies that that 3 is repeating forever and ever. Okay, and the reason why this 0.3 repeating is considered rational is because it can be written as 1/3, which is a ratio of two integers. Okay, so rational numbers in decimal form are either terminating, which means it ends, or it's repeating. An integer is a positive or negative whole number, or 0. Okay, so it's going to be your counting numbers and their opposites plus 0. Whole numbers are the positive integers and 0. So 0, 1, 2, 3, 4, and so forth. Whole numbers have no fractional or decimal parts, and they do not include negative numbers. So you won't see fractions or decimals when we talk about whole numbers. And then a natural number is a positive integer greater than 0, and then negative numbers and fractions are not natural numbers. So your natural numbers are whole numbers except for 0. So it would be 1, 2, 3, 4, and so forth. So there's this diagram that's down here that kind of encompasses all of these things. Okay, so the big outside kind of square, rounded square, or actually I should say rectangle, rounded rectangle, says rational numbers. So remember, rational numbers can either be terminating or repeating decimals, okay, and it's an integer or a ratio of integers. So here -4 over 5 and 0.75 are examples. Now you see how these rectangles here kind of overlap with each other. So a rational number includes integers, whole numbers, and natural numbers. Okay, so rational numbers include these things, okay, but these numbers that are in this outside rectangle here aren't considered integers, whole numbers, or natural numbers because they don't fit that classification. So then the next rectangle is integers. Okay, so those are our positive, negative, whole numbers, and 0. Whole numbers are positive integers and 0. And then our natural numbers are the innermost rectangle here. Okay, so those are just positive integers greater than 0. Okay, so those are some classifications that you should be familiar with from your previous math courses. So now we're going to look at irrational numbers. So continuing with example 1, the example for this says, how would you classify the number 0.24758326, and those 3 dots means that number keeps on going. Okay, so it's doesn't stop. It's not terminating, so it keeps on going. So how do you know whether the decimal is a terminating decimal? So here the decimal expansion does not terminate or repeat, so it cannot be written as a ratio of two integers. Okay, we know it's not terminating because of these three dots. That means it keeps on going. So this number is not terminating. Okay, so it's not a terminating decimal. The three dots at the end means that the decimal goes on forever. Okay. Now, you should notice, though, that there isn't a pattern going on. Okay, I just have numbers 2, 4, 7, 5, 8, 3, 2, 6. Nothing's repeating, so I can't say that there's a pattern going on here. So this decimal is neither terminating, so again it doesn't stop because it has those three dots, and it's also not repeating. So what is this number that we have here? We have to classify this number somehow. So that's where we get to this definition of irrational. Numbers that are not rational are called irrational. Okay, so an irrational number is a number that cannot be written in the form A over B, where A and B are integers and B does not equal 0. So irrational can't be written in fraction form. It can't be written as that ratio. So here we have rational numbers. Okay, integers, whole numbers, and natural numbers are considered rational. And then we have this category of irrational numbers that can't be written as a fraction. So that's what we're going to be looking at in the lesson today. We're going to be looking at what are irrational numbers. So one example is something like this, where we have a number that keeps going forever. It's not terminating, it doesn't end, and it doesn't repeat. So if, just extending this a little bit, suppose this decimal that we were just looking at, it looks very similar, suppose the decimal was written as 0.247583326. Would this decimal be a rational number? So in order for it to be a rational number, 1, it needs to terminate. So does my decimal end? Okay, I don't have those three dots anymore. So yes, it ends. Okay, so here this would be considered a rational number. Yes, it is rational because it ends. So yes, it is rational because it terminates. So again, when we looked at the vocabulary at the beginning of the lesson, in order for it to be a rational number, the decimal either has to 1, terminate, or 2, repeat. Okay, this one terminates, therefore it is rational. Okay. Underneath example 1, there is a try it problem. It says classify each number as rational or irrational. So go ahead, take a moment, pause the video, and answer this question. When you're ready to check your answer, you can unpause to check your work. So here in this example, we have pi 0.4053661, and then down here 0.76 with a bar over it. So that means it's repeating. And then here 3.56555556, and those three dots means it's going to keep on going, so that's not terminating. Negative 17, and then 3.275. So we have to determine whether they are rational or irrational. So let's look at pi. So pi is a number that does not repeat and it does not terminate. So it would be irrational. This second one here, 0.04053661, and those three dots means it doesn't end, so it's not terminating. Now the only way this would be rational is if it repeats. I don't see a pattern here, so it's not terminating and it's not repeating, so that means it's going to have to be irrational. So 0.04053661, and then it keeps going. Over here, 0.76, the 76 is repeating. So that means it's 0.767676, and that keeps on going forever and ever. So here, in order for it to be rational, either 1 has to terminate or 2 has to be repeating a decimal. So it doesn't terminate because it keeps on going, but it does repeat. It has this pattern of 767676. So that means it's rational. So 0.76, and the bar goes over the 7 and the 6. Okay? The next number is 3.5655655556. 3 dots means it's not terminating. So in order for it to be rational, I have to have repetition. It has to be repeating. Now there is a pattern here, but it's not a repeating pattern. So that means it's going to be irrational. So 3.5655655556, and that keeps going. Negative 17, okay, that's an integer, so that is automatically a rational number. And then the last one, 3.275. It is a terminating decimal, therefore it's rational. So 3.275 is rational. So now let's go ahead and look at example 2. So we're going to introduce another vocabulary word. For example 2, we are going to be looking at identifying square roots as irrational numbers. So square root might be a new vocabulary word for you, so we're going to talk about that in a moment. So the example says classify. This symbol here means square root of 3. So classify the square root of 3. So we have to identify what category this is going to fall in. Is it rational or is it irrational? So the square root of 3 means the non-negative square root of 3. The square root, okay, new vocabulary word for some of you, the square root of a number is a number that when multiplied by itself equals the original number. The radical symbol, okay, which is like this little check mark with a little extension on top, a little house, the radical symbol is used to denote the non-negative square root. Okay, so square root, okay, we have to find a number when multiplied by itself equals that original number. So here, is there a number that's multiplied by itself to give me 3? Okay, that's what we're thinking of. So in order to do that, it's helpful to know your perfect squares. Perfect square is a number that is the square of an integer. So when I take the number, say 1, and square it, I'm multiplying it by itself. So 1 times 1. Okay? And that product then is considered the square. Okay? The perfect square. So 1 squared, 1 times 1 gives me 1. 2 squared is 2 times 2, which gives me 4. 3 squared is 3 times 3, which gives me 9. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. 6 squared is 6 times 6, which is 36. 7 squared is 7 times 7, which is 49. And that list continues, okay? But those are some that you should be familiar with. It might be helpful to jot these into your notes so you have them to easily reference. So these are all perfect squares. 1, 4, 9, 16, 25, 36, and 49 are perfect squares. So when I have a perfect square, I can take the square root of it. So the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. So these numbers that are perfect squares, you can take the square root of them. It's just the result is the number that gives you what's underneath this house here, what's under the radical symbol. If it can be multiplied by itself, that's the answer. Okay, so 2 times 2 gave me 4, which is why the square root of 4 is 2. So here, dealing with the square root of square root of 3, 3 is not a perfect square, okay? So since 3 is not a perfect square, you can't simplify it, okay? And since we can't simplify it, that's going to mean it's irrational, okay? If you can't simplify a square root because it's not a perfect square, it's going to be irrational, okay? So that's something that you have to keep in mind. So square roots that can't be simplified, irrational. So now we're going to go ahead and look at example 3. We're going to look at these 4 numbers here and identify whether or not they're rational or irrational. So it says classify each number as rational or irrational, and then explain how you classified each number. Okay? So as a reminder, irrational numbers are decimals that are non-terminating and non-repeating. So they keep on going forever, but there's no repetition. There's no pattern going on here. There's no repeating pattern. And the second thing that we just looked at in example 2, it's a square root that can't be simplified because the number under the radical symbol is not a perfect square. So here, this first number, negative 81,572. I don't know why I had trouble saying that, but negative 81,572. Now this is an integer, so it's going to be rational. So we'll put that in the rational box. The next number is the square root of 11. Now, was 11 one of our perfect squares up here? So I had 9 and 16, 11's in between there, so 11 is not a perfect square. So it can't be simplified, so that means it's going to be irrational. This next number is 5.636336333, okay? And those 3 dots means that it's going to keep on going, so it's not terminating. So that's one part of irrational number. And then it also can't repeat. So you see that there's a little pattern going on there, but it's not a repeating pattern. So when it's not a repeating pattern, that means it's irrational. So 5.636336333 is irrational. And then the last number, the square root of 16, 16 is a perfect square, so that means the square root of 16 is equal to 4. Okay, and 4 is rational. So since the square root can simplify, it means it's rational. So the square root of 16. There's a try it problem that goes along with example 3. Okay, at the bottom of your page. So pause the video, take a moment to answer this question. You're classifying each number as rational or irrational. Once you have a chance to answer it, you can resume the video to reveal the solution. So 2/3 is rational. It's a ratio of 2 integers. The square root of 25 equals 5, so it's going to be rational. Negative 0.7, and that 5 is repeating, so it's 0.755555. Okay, that's not terminating, but it is a repeating decimal, so that is considered rational. The square root of 2, 2 is not a perfect square, so that's going to be an irrational number. And then the last one, it terminates. It doesn't repeat because there's no decimal. Okay, so it's a terminating number, so it's considered rational. So 7,548,123. So the only number that is irrational here for this one is the square root of 2. So to recap the key concept, we talked about rational versus irrational. Okay, and we talked about integers, whole numbers, and natural numbers as well. So rational numbers can be written as a ratio of two integers, or as decimals they are terminating or repeating. And then irrational numbers, we looked at decimal form. So in decimal form, they're not repeating and not terminating. And then we also looked at square roots. Square roots that are irrational are not perfect squares. So an example here is the square root of 2. 2 is not perfect, so it can't be simplified. So it would be considered irrational. Okay? Now, underneath the key concept, there are some do you know how problems. Go ahead and do 4, 5, and 6. So pause the video and then resume the video when you are ready to check your answers. So do you know how 4, 5, and 6. So for number 4 is the number 65.43492224, and then those 3 dots means it keeps going, rational or irrational. So here, this number is going to be irrational. And the reason why, irrational, because it is not terminating and it does not repeat. So that's why it would be irrational. It's non-terminating, so it doesn't end, and there's no repeating pattern, therefore it's irrational. The next example, number 5, it says, is the number the square root of 2,500 rational or irrational? So here, the number is rational because 2,500 is a perfect square. So 50 squared, or 50 times 50, gives me 2,500. So that means the square root of 2,500 equals 50. So that would be a rational number. Number 6, it says classify each number as rational or irrational. So the first one, 4.27, and the 7's repeating, so that's going to be rational. 0.375 terminates, so it is rational. 0.23234245 keeps going. It does not terminate, and it does not have a repeating pattern, so it is irrational. The square root of 62 is irrational. 62 is not a perfect square. And then the last one, negative 13 over 1. That's a ratio of two integers, so it is rational.